Okay, guys, so what we're going to do is we're going to take the idea of proportions, right? We're going to use it in a different way, and actually, right, it's just an extension of yesterday's lab. So what we're going to do is we're going to talk about similar figures and kind of see some problems and how mathematically that they work. You already have a good idea. Okay, so hopefully this will be fairly easy, but we'll talk a little bit more about it. So here we go. The very first word I want to talk about is the word congruent. Everyone? So here's what your book says. These are line segments that have the same length, or the angles that have the same measure, or figures that have the same size and shape. Okay? So in your little box off to the side, go ahead and write down twins. Now, here's why I say twins, okay? Because if you have two people who are identical twins, now they very much, at least a majority of the time, right? They look identical. They're very close. I mean, they might have little things that are different, right? But for the most part, they're identical. If you look at them, you don't know them, you probably can't tell the difference between the two most of the time, okay? Same size, same shape, everything, all right? Put the same clothes on them, they'll be exactly the same. But here's the thing. Are they the same person? No, they're not, right? That is like congruent figures, or even congruent line segments or congruent angles. They have the same size. Everything about them looks identical, except they're not exactly the same. So you call them congruent, okay? So that's what the word congruent means. All right, our next word is this. Corresponding parts. Everyone? Corresponding parts. All right, so this is kind of what we hit upon quickly yesterday, but now we're going to really talk about this. Here's what this is, and it's an extremely important word or phrase when it comes to similar figures. These are parts of congruent or similar figures that match. Parts of congruent or even similar figures that match. So remember, congruent means there's two, let's say, triangles that look, they're not the exact same triangle, but they could be exactly the same size and look exactly the same. Okay, but they're just not the same. Similar, right, means that we talked about it yesterday, that they're pretty much, sides are proportional to each other. It's a reduction, right, or another one that's an enlargement of another, right? So one's smaller, one's bigger, but they're proportional to each other, all right? Both of these type of figures have corresponding parts. Now, you might look at that and you go, okay, what does that mean? So here's what I want you to do. It's better to actually show you where it makes a little more sense. Okay, what I would like you to do, don't draw the parentheses, but in your little box, go ahead and draw those two triangles. Make them look almost identical to those right there. Do the best you can. Okay, draw those two just like that. Make it look exactly like that the best you can in your small box off to the right. Okay. No, I'll give you guys a few more seconds. People are still drawing. All right, now, listen carefully. With these two triangles, okay, they might be similar, but they actually look congruent to each other, okay? The bottom line, though, is that it's like you took this one and there was some rotation to it. There's not only rotation, all right, but there could be translation, meaning that it's just kind of, it rotated this way and moved over. Okay? Now, corresponding parts are important because to be able to find out if these two things are proportional, you need to be able to match up corresponding parts. So, this is very vague. Parts of congruent or similar figures that match. Okay, but let me show you what that really means. If these two are congruent with each other, what I would say is this little small part here, we'll call that side 1. That its corresponding part is that part right there of that triangle. You might say, but Mr. Wilkins, that one's on the bottom, but that one's on the left. You're right. but it's the same. It's just been rotated. Okay? However, that is a corresponding part there. Now, if I take a look at this, okay, if we call this the base, for example, this would be the height of this triangle. Okay? This side, basically to kind of like counterclockwise, I guess you'd say, from the base is what we can call our height. Okay? This one here, rotated, or if I go around counterclockwise, is its corresponding side. Okay? They match. Now, this is called a hypotenuse, and you guys will, if you haven't heard that, you'll hear it in the future. This is a hypotenuse. Okay? If this was a right triangle, that is. It's basically its longest side. This is a corresponding part with this. So you can't say, oh, it's the one on the left, because if that was the case, this is on the left and this is on the left. That's not the case. It's the ones that would match, even if there was rotation that happened. Okay? So, usually showing you works a lot better than the actual definition. But if it still doesn't if it still doesn't make sense, this is one of those times where this is a crucial piece for what we're about to do. You don't want to have to worry about being able to see corresponding parts. You want to be able to worry about the actual math that goes into it. So you should be able to identify them fairly quickly. So guys, questions about corresponding parts? Okay. All right. So if there are no questions, then here's what we're going to do. All right, go ahead and grab your book and flip over to page 235. 235. All right, I made a mistake, and I should have taken my textbook and ran a copy where I didn't have to do this. But while you guys are taking that out, I'm going to go ahead and draw these lines here. I'm going to do the best I can. Okay, so for number 5, this section, the directions say the figures are similar. So it's not saying are they similar. We're not testing it. They're saying they are similar. That means that this one looks like a reduction of this one. Okay, it's a smaller version. Okay, yes, they're not in the same orientation. This one is actually flipped over, right, and moved up a little bit. And it's smaller, but they're similar. They're proportional to each other. Okay, it's a reduction. That's what that first part says. The figures are similar. Then it goes on to say, find each missing measure. Now, the missing measure on our homework is talking about, they want you to find what's x. Okay, what's x? Now, I could actually teach you a couple of ways to do this. I'm going to try to stick with one way. All right. There's actually many different ways I could solve this problem, but I'm going to just show you one way. All right. And here it goes. Okay. Step 1. Okay. Here's what I want you to do. Take your missing side. In this case, maybe I'll call this the height of this. And write a ratio of it to another part. Well, I'm going to try to keep it easy on myself. I'm going to go ahead and put it over the base. So I'll just say like the height over this base here. Now, step 2. Because they're similar, that means they're proportional. So what we're going to do is we're going to write a proportion. Now in the past, remember I always say, guys, please make sure units, the same units are side by side. Now the issue with this is that all the units are in kilometers. So you can't necessarily name it like that. Here's what you're going to name it. Step 2, corresponding sides are side by side. So here's what that means. If this is height over base of this one, it's going to be equivalent to the height. Notice how I went over here. The height is on the right side over here, right? A corresponding side. The height over the base here. If you notice, I did not just grab some random numbers. Okay? So step 1, let me review so far. We're not done, of course, but let me review. Step 1 is take your missing number and write a ratio of it to another piece or another side on that particular figure. So in this case, I just did x over 10. And then because they're similar, I write a proportion with corresponding sides side by side. So because this was height over base, I made this height over base. So 6 over 4. Now comes step 3. Ladies and gentlemen, I'm going to solve. And I'm going to solve, just a little reminder here, use cross products. So I know that this times this is equal to this times this. Notice how when I write this, 4 times x equals 10 times 6. I have noticed on a lot of students' papers lately that they do this and then they try to figure it out in their head and in the calculator. I want to see an equation. Write your equation. This is getting you ready for larger problems and future problems. And it's giving you extra practice on how to solve equations, which is also coming up here in the near future. So, I'll draw an arrow over here since I wrote the step way over there. So we have 4 times x, which is just 4x, right? We're going to simplify both sides, equals 60. And then, right, we're solving for x. It's being multiplied with 4, so we do the inverse, or we do the opposite. We divide by 4. And we have to be fair, do it to both sides. So we end up with x equals. Now, many of us could probably punch that in the calculator if we wanted to. I don't need to. 60 split in half twice is 15, right? That's what dividing by 4 means. Now, we probably should do this. Step 4. Because this is a geometry problem and has units, don't forget your units. What are the units of measurement in this problem, guys? Kilometers. Put those on there. So that missing side right here is 15 kilometers high. I'm hoping step 3 and step 4 are the easy ones. That should come, you know, as just an easy part of the problem, right? Because we've been working on that for a while. So you can still ask questions about step 3 and 4, but are there any questions on step 1 and step 2? Because that is the main part of this lesson.
Do you have to draw the figure?
You do not have to draw the figure. I drew it because I needed to write on it to show you guys a visual. So you do not have to draw the figures. That's a great question. Okay. You need to pay close attention to them to create step 1 and 2, but you don't have to draw the figures. Okay. And, oh, I'm sorry. Unless there will be some today that you'll see. Okay, I can't remember if it's this lesson or the next, but there are some today where we will be drawing figures. But on this particular one, you don't have to. Sorry.
So when you put the variable over a number, like one number,
Okay.
it could be either 25 or 10.
So, great question. So remember I said there's a lot of different ways we could have solved it. You actually could have put x over 25. But what this would have then been was 6 over 10. And believe it or not, you would have gotten the same answer. So that's what I'm saying. There are a number of different ways. As long as you follow these steps, it doesn't have to be exactly the same side. I don't have to choose the same sides that you choose, but this is the proper way to set it up, as long as you're consistent. Now, if I go, oh, x over 10 is equal to 6 over 10 over here, you're going to get it wrong, because those aren't corresponding sides, side by side. So you just have to be careful. especially with step 2. That's very important. But yeah, as long as you find, you could have used, yep, x over 25 equals 6 over 10, and you would have still gotten the 15 kilometers. All right, guys, any other questions? I'm going to have you guys try one. You ready? Okay, I want you guys to do problem number 6. Problem number 6. All right, go. Okay, how many of you need more time? Okay, check with you in about 30 seconds or so. If you guys want to work on those top 4 while we're waiting for others, make sure you do it. Okay, get part of your homework done right now. All right, checking in. How many of you still need more time? Okay, 30 seconds. All right, go ahead and share your answer. Go.
I got 90.
All right. So it probably would have been a great idea if I would have drawn this while you guys are working on it. All right, here we go. Okay, I'm not going to worry about the corners right now, the points, okay, because on this particular problem it doesn't matter. So just for timing purposes, I'm going to go ahead and do this. So same directions, right? However, right now we're solving for this. So here's what I'm going to do. What I'm going to do is let me go ahead. On this particular one, I'm going to go ahead and take my missing part, right, and write a ratio of it over the base of this one. So x over 6. And then I'm going to set up my proportion, right? And this is this top part here. Now, the only thing that's different on these two is this is smaller and it's flipped, right? So what I'm going to do is this part here's corresponding part is this. So instead of x over 6, I'm going to go 12 over 8. So there's my proportion. Since they're similar figures, that works. I'm going to use my cross product. So 12 times 6 equals 8 times x. Okay, 12 times 6 is 72 equals 8x. And of course, I could divide both sides by 8 and get x is equal to 9. And ladies and gentlemen, my final answer is, I'm looking at my units, 9 feet. All right, questions?
Wait, so to check our word, check the word, so could you also check it so not on the bottom it says 8 feet and then on the next one it says 6 feet?
Uh-huh.
Couldn't you divide 8 by 6 and then you see that and then you multiply and then you divide 12 by 1.3 so that it equals and then you get 9, check it.
Okay, so here's, you see me after class, we'll talk about it. I'll see how you set it up to see if you got it right. But like I said, there's a number of different ways to do it. Unless you double check with me after class, I want to see it this way. I don't want you guys to start making up your own ways to do things and try it this and be experimental, because that's not what we're in this class to do. But there are other ways, and if you get my okay about a certain way, then you can come and talk to me, but you have to talk to me for me to okay it before you do. So it might be right, all right, but I want to take a look at it first. Other questions?
So we don't need to worry about the other variables, just the variable with the unit measurements?
Say that one more time.
So we don't need to worry about the other variables like L and N?
Okay, so great question. All right, I take it for granted because I sometimes overlook it. So if you guys take a look, let's just use number 5 for example. These endpoints right here, all figures in geometry. We'll get into geometry in the future here, but all figures will have points upon that figure. This here is called side AB, or line segment. You could even call it a line segment AB. Okay? This figure you could name as figure ABCD. This is figure JHLK. You name figures, you give them names by these points. Okay? They are not variables. Who can tell me what is the difference in visually between those and variables? What's the difference? Does anyone recognize it? Okay. They're capital letters. Guys, it's so funny because in math, those little bitty things actually have meaning. Okay, it's like a code. It's a math code. Capital letters are points. Lowercase letters, most of the time in algebraic formulas and things, those are variables. Okay, so the variables will stand for a number. Those are usually used in geometry for points, capital letters. Okay, so thanks guys for bringing that up, but that's a really good point. So don't get confused. Those aren't variables. Those are points to name that. And we'll see it in future problems here. Okay, any questions guys on that? Okay, here's what I want you to do now. Let's go ahead, let's take a look at problem number 9. Let's go ahead and close read this here. It says triangle LMN is similar to triangle RST. What is the value of LN if RT is 9 inches, MN is 21 inches, and ST is 7 inches? So, listen carefully. So it's kind of funny because you guys have asked some really relevant questions here. First off, remember the question earlier that asked, Mr. Williams, do we need to draw those? No, not on those problems. On this problem, yes, we're going to need to draw them. Okay? Here's the second thing. Is about the letters that was just asked, right? They're all capital letters. They are naming it. So when we draw it, we're going to draw it based off of the name. So here's what we're going to do. First, we have triangle LMN. It doesn't tell us what kind of triangle it is. It doesn't matter. You guys, if you want to on your paper, you can draw an equilateral triangle. I could draw an obtuse triangle. Whatever the case is, but here's what's most important. Okay? Triangle LMN. So step 1 is draw your triangle. So I'm gonna draw a right triangle here. Kind of like our vocabulary. Now listen, I don't really care. It doesn't have to be to scale. Okay, what that means is you don't, if you mess up and you're labeling it or something like that and it doesn't make sense according to the dimensions or the lengths of the sides, don't worry about it. Okay, that's not really important right now. So I'm going to draw this, and it says triangle LMN. Here's what I'm going to do. I'm going to choose a point to start with. Many of us might want to choose the very top point, and that's okay. L. I'm going to go clockwise because for most of the time it's kind of natural. So L, I'm going to go right here. M, N. Now, also part of step 1, let's draw our similar figure. Remember, it's proportional. Now, at this point, it doesn't say which one is which one's larger, which one's smaller. I don't know. And realistically, it really doesn't matter. Okay? Here's what does matter. Let's go ahead and draw a similar triangle. There's no need to make it harder on yourself and rotate it or anything else. Let's just draw kind of I'll just draw a larger version here. Just pretend that it's there. You know, it's not perfect, but let's pretend it's similar. Okay, it's just an enlargement of the other one. Now here's what matters. I'm going to label this triangle exactly how I labeled the other one for it to be accurate. I'm going to label this exactly. So I started on the top, went with the first letter in their naming, and I went clockwise around L, M, N. I'm going to do the same thing with this one. Here we go. R, point S, and point T. Okay, here we go. Step 2. I'm going to label. Be very careful. If you label the wrong sides, it's going to be wrong. You have to be very precise on these. So here we go. The first description, it says, what's the value of Ln? By the way, what's the value of Ln means that that's what we're going to solve. Well, just like the last problem, let's go ahead and put an X there. Ln. There's no other Ln except right there. Ln. L to N, that's the length that we're needing to solve. So it says, what's the value of Ln if, here we go, RT is 9 inches. RT, 9 inches. I'm going to label it 9. I'll even put the IN here. 9 inches. MN is 21. So where's my MN? Right there. MN is 21 inches. And ST is 7 inches. ST is 7 inches. Now, you see what I'm saying? That there's no way that that's 21 if that's 7, right? That's actually smaller. So that's what I'm saying. Don't freak out if it's not, if you know, 1 is supposed to be an enlargement. It didn't tell us. It's not a big deal. Okay, what matters is that we made them similar. We labeled them correctly. They're still similar. These measurements are going to be proportional to each other. Okay? So here we go. Step 3. Here's what we're going to do. Because we just did this problem up here. On this problem, here's what I'm going to do. I'm just going to write, set up your proportion. And you're going to do it exactly like we did with step 1 and 2 up here at the top. So remember, set up a proportion. Here's what I'm going to do. X over, and the only other one we have here is 21, right? So X over 21 is proportional to, and it went basically the height over the base, right? So the height here is 9 over the base, which is 7. Okay? All right, step 4, solve. Now, on the last problem, right, step 4 was solve and use cross products. And you're going to need to do that on many of them. Do we need to use cross products on this one? Well, you can if you want. But last time I checked, I can use the old elementary school way. 7 times 3 is 21. What's 9 times 3?
27.
There's enough problem here. If you come across a problem that is easy like this, make sure you use it. Okay, now of course step 5, Step 5 is put your units, and it's in inches. 27 inches. If we were doing a problem just on cross products, I'd want you to do cross products. My assumption is, and where you should be, is you should be good enough, and it's like cross products is a tool in your toolbox. When you need it, you take it out. When you don't need it and you can solve it using the elementary way that your elementary teachers taught you, use that one instead. It's a lot easier. Okay? But you're not going to be able to use this all the time. So you might always want to check for this skill, but if you can't use that skill, that one's a go-to right there. This works sometimes, that works all the time. So, but if you can do it the simpler way, do it. Okay? There's enough issues with us solving these big problems to begin with, right? All right, questions?
That problem, do you want to put x equals 27?
No, because we used x as a variable to represent our missing side, but the real question in that is what's the value of ln? And so the value is, if you did x equals 27 inches, perfect, that's okay. Okay, but if you just put 27 inches, that's okay too. Just make sure you guys put your units, that's important. All right, guys, any other questions? Ready to try one? Any questions on the drawing? The drawing is important, and how I labeled it and everything. If you don't do that accurately, it's going to throw this whole thing off. Okay, you'll probably be able to find out when it's thrown off sometimes anyway. Because if I labeled this x and this 21, then you'd be like, wait, x over 21, but 9 over what? I don't have that. You know what I mean? So if you labeled it wrong, you got to go back and check. That's how you can catch your mistakes. Unless you labeled both of them wrong. But actually, even if you did, maybe you coincidentally could get it right. Still, that you still want to label it correctly. Okay, guys, questions? Okay, problem 10. Problem 10, go. Check in with you guys in 2 minutes. Okay, who needs more time? Okay, checking in about another 30 seconds or so. Are any of you still in need of more time? Okay. Okay, checking in. More time. Anyone? Okay. 30 seconds. Go ahead and turn to your neighbor and share. Go.
I got 8.1. Oh, yes.
Never mind.
Okay. Majority of you guys are still talking about this problem, so I kind of let it go for a while. But let's come back here. Make sure you guys check your work. Okay, so here we go. This time it's not a triangle, right? It's a quadrilateral. Well, I'm not gonna make some fancy quadrilateral. I'm gonna make it as easy, as possible. Last time I checked, a nice little rectangle is a quadrilateral. So I'm gonna go ahead, build a rectangle. There's my little rectangle, and that is A, and I'm gonna start on the top left, A, B, C, D. I'll go around clockwise. Then what I'm going to do is I'm going to draw a slight enlargement, let's say like that. Let's just pretend like they are similar because that's what it says. And it's W, X, Y, Z. So I'm going to start in the same spot. W, I'm going to go clockwise. X, Y, Z. Then it goes on. Here I go. I'm going to label. It says, what's the value of WZ? So here we go. WZ, that's my X. That's what we have to find out. What's the value of WZ if, here we go, AD is 18 feet, so there's AD, it's 18 feet. CD is 27 feet. CD is 27 feet. And YZ is 10.8 feet. YZ is 10.8 or 10 and 8/10 feet. All right, here we go. I'm going to go ahead and take my X, put it over. Again, it just happened to be like the way I drew it, that it was the height and the base. All right, might not have ended up like that on yours. That's okay. But I'm going to take the X and put it over 10.8. And it's going to be proportional, so equal to. And then my height over my base, so my height over my base. So 18 over 27. Now, this one obviously isn't the 6th grade method, right? So I have to use cross products here. So 18 times 10.8 is going to be equal to 27 times X. So that gives me 27X equals, and grab my calculator. That's missing on my desk. Here we go. 18 times 10.8, 10 and 8/10 equals 194 and 4/10. Of course, I need to isolate the variable, right? Get x by itself, so I do the inverse. I do the opposite. That's multiplication, so I'm going to divide by 27 here. I'm going to be fair, do it to the other side of the equal sign, other side of the equation. This cancels. I end up with x equals, and now 194.4 divided by 27 equals 7 2/10. Okay, and I take a look at my units, so it's 7 2/10 feet. There we go. Guys, I understand, like I've seen in our work, some of our work this year, that a lot of us are moving fast. We're looking for quantity over quality, and we don't pay attention to the small things. And some of us, it's kind of kept us from that A in this class, okay? I'm not saying everyone, but some people. Here's my whole point. You have to be careful about the little things. You have to be very precise, especially when it comes to this. I was very careful with where I started, how I labeled it, kept it consistent on both. I made sure, I mean, there's a lot of little details in this thing. So you have to label it correctly, and then, you have to then make your proportion carefully. You can't get sloppy there, right? And even with the calculations, now using a calculator, so you have to, there's a lot of little things involved things that can go wrong. So be very careful. Okay, slow down and make sure you're doing those. Okay, here's what I want to take a look at. One other last type of problem. Let's take a look at number 11. Okay. Okay, so here's what we're going to do. I'm going to go ahead and grab my graph paper. All right. I grab my graph paper, and the graph paper, on the problem for number 11 says, using a scale factor of 2/3, draw and label a rectangle similar to the rectangle ABCD. So, ABCD, it shows, has the height of 6. So, 1, 2, 3, 4, 5, 6. 6 centimeters in height. And the base is 9. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go ahead and close it up, of course, to be my rectangle. Okay, so now what they're doing is they're, of course, doing a little bit of yesterday's problem with today's problem. Okay. Actually, this is a little more like yesterday's problems, right? It's more like yesterday's lesson. So this is a little bit of review. So here's what I'm going to do is they give us a scale factor, right? As we learned yesterday, using the scale factor. So we do, the important part is we figure out one side at a time, right? So let's talk only about the height first. I'll go ahead and label height. And height is done by taking the height of this, which is 6 centimeters, and multiplying it with the scale factor of 2/3. Now this is like 6/1. So to be able to get the height, here we go, do a little cross reducing, right? And get 2 and a 1 there. That gives me 4/1, which ends up being 4 centimeters. And like we talked about yesterday, the base. And guys, you know what? I mean, I didn't write the steps because we did talk about this yesterday, right? But if we were to do the steps, step 1 is draw your original item appropriately, right? With the right measurements. Step 2 is figure out one of the dimensions by multiplying by the scale factor. Step 3, find out the other dimension by multiplying by the same scale factor, right? So it's so the base is 9, or in this case 9/1, because we're going to multiply it with 2/3, or 2/3. Cross reduce on these as well. Divide both of them by 3. We get 1 and 3. Sorry, my computer's in the way. I ended up down there. So 9/1 times 2/3, cross reduce by 3. 1 and 3. When I multiply straight across, it's 6/1, which ends up being 6 centimeters. And so, here we go. I'm going to go ahead and say the height it says is 4 centimeters. So I'll go here. So I'll start down here. 1, 2, 3, 4. And the base is 6 centimeters. So 1, 2, 3, 4, 5, 6. Close it up. I'll label it 4 centimeters and 6 centimeters. Let me reread the problem. Using a scale factor of 2/3, draw and label a rectangle similar to a rectangle ABCD. So, I guess you would say this was all step 4. I drew it and labeled it. And there's our answer. Okay. All right, so lesson on similar figures.